Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So we will continue discuss question number 9. So an electron transit from ground state to higher energy level, then it fall back to produce the third line in Lyman series. So we have two information. It transit to higher energy level and it fall back to produce third line in the Lyman series. So we know that the Lyman series mean it fall to n equal to 1. So the third line in Lyman series mean, let's say this is the Lyman series, n equal to 1, n equal to 2, n equal to 3, n equal to 4. The first line is 2 to 1. The second line is the transition 3 to 1, and the fourth line is the transition and the third line is the transition 4 to 1. Means that for this question it transit from n equal to 4 to n equal to 1. Okay, now calculate the energy occupied by electron at higher level. So energy at higher level means that energy at specific n. Okay, so how to calculate? So in this case we can apply E is equal to negative RH 1 over n squared, because it is at specific level. So negative 2.18 10 to the power of negative 18 joule 1 over 4 squared. So the answer is negative 1.363 10 to the power of negative 19 joule. So this is the answer for energy at n equal to 4. Okay, now we look at question B. Calculate the energy emitted. So you supposed to know that the energy was emitted when an electron made a transition. So when it's made a transition, to calculate the energy, we supposed to apply delta E is equal to RH 1 over n initial squared 1 over n final squared. To produce the third line in Lyman series, the electron made a transition from 4 to 1. So 2.18 1 over 4 squared 1 over 1 squared. So the answer is negative 2.044 10 to the power of negative 18 joule. Okay, and then C, determine the wavelength and the frequency correspond to the above transition. So we want to determine the wavelength and the frequency. So do you still remember that we have a formula that involves energy, and we can determine the wavelength and the frequency. Delta E is equal to H frequency. We already have the delta E, but make sure we use the value only. So 3.083 10 to the power of 15 hertz. And what about the lambda? Lambda is C over frequency. So C over frequency, sorry. We already have 3. Divide by 3.083, 10 to the power of 15. Okay. Okay, we have 9.74, 10 to the power of negative 8 meter. Since we want to give the answer in nanometer, so we become 97.4 nanometer. Okay, and the last one is, what is the question? Last question. Draw the energy level diagram that indicate the transition. Maybe this is the answer for number. Okay, I use this as the answer for D, but no need to draw this. Okay, this is the answer for D. Alright, so that's all. So thank you very much.